I'm sure that before you left the house this morning, you paused for a moment and asked yourself, what should I wear? Something comfortable? Maybe an extra sweater in case the air conditioning would be too cold? Or maybe I'm presenting today, so I need to be a bit more formal. Now imagine you are a farmer at the 18th century. Would you wear the same clothes? Probably not. You'll need something durable, heavy-duty, that could stand sun, rain, and long hours of physical labor. A garment that moves with your body and understands the needs of manual work. 300 years ago, before the invention of the elastic fabrics, there was a secret, passed through generations, a way to make stiff, woven textiles flexible and comfortable enough for hard labor. That secret was called smoking embroidery, a clever embroidery technique that used special gathering to add stretch exactly where the body needed it. That's how they could move and work easily in the fields. Then came the Industrial Revolution, and suddenly this labor-intensive embroidery was no longer needed. Smoking became just a decoration for the royalty clothes. Eventually it faded, surviving mostly in museums. Almost 20 years ago, when I studied fashion design, during embroidery class, our teacher introduced us to this amazing technique, and I immediately fell in love with it. There was something about it that I haven't seen before in other embroideries. It wasn't just beautiful. It made sense. It was smart and it was functional. It carried a wisdom. When I started researching this embroidery, I realized it was made from a grid of dots, kind of a rule-based system. For me, it felt like a primitive algorithm. And I couldn't let go of one thought. What if we take this ancient knowledge and combine it with new technology? What new world would it open for us? For a whole year, I worked with 2 computer scientist partners researching this technique. We created over 1,000 of samples, shifting dots, changing stitching order, exploring what will happen when we disrupt the traditional pattern. The result was a beta software. We developed 8 new algorithms. Each one is producing a unique, different quality to fabric, such as axial movement, structural strength, 3-dimension, and more. Imagine a textile that supports itself, stretches only in certain directions, or adapting to changing conditions. Each object is crafted by a different algorithm, creating a new, different quality to fabric. Some of our prototypes even stand as tall as human scale, held together by nothing but algorithmic logic and hand stitching. Sewing is a key technique to many industries, shaping not just material, but the entire structure. We created an open source platform that allows anyone who wants to use this tool for designing smart, functional objects. From architecture at large scale to nanotech and biomedical design. The goal of this project was never to replace craft with new technology, but to amplify it, not to push tradition aside, but to use technology as a way to strengthen it and to preserve it, to let it evolve. Thank you.